For those of you who are listening online, come check out our meetup group at meetup.com/svbigdata. And I hope to see you in person or virtually or in our YouTube channel. All right, so with that, Nadine, take it away.
Yeah, so yes, my name is Nadine, and today we're going to talk about real-time analytics on data lakes, meaning like how can you index Amazon S3 for an incredible improvement on queries. And so on the first page, we have a little fun character. Pharaoh joined the team on September 7th, and that's this little character over here. And I'm pretty excited to introduce this to our community, and you'll be seeing Pharaoh quite a bit. Where, Pharaoh's getting ramped up, so Pharaoh should be making some upcoming things pretty soon. But yes, before we begin, we're going to be doing, at the end of this tech talk, we're going to be doing a workshop where we're actually going to index S3 data. So if you are interested in joining the workshop, you can please create a free account at rockset.com. You can do a free trial. You do not need to insert your credit card or anything like that. And as part of the workshop and posting your results on the Rockset community afterwards, you'll be eligible to do for these giveaways. And I'm going to be doing up to like $400 in giveaways today in gift cards. So like, let's get some swag out. I know you guys are here after a long day, so I can't thank you enough for joining this tech talk. And I hope you guys get as much out of it as you can. And if you and please post questions as they come. Okay, so we already gave a little intro about me, but yes, previously I was at Bose. I was working on the watchOS SDK. My background primarily in connected products, IoT, and databases, where I was at Storage, formerly building out distributed object store. So in the agenda, we're going to first talk a little bit about what the state of data lakes are currently and how people are using it right now and the trends kind of we are seeing. From there, we're going to talk about how your applications can be powered by real-time analytics with data lakes with seconds in data latency and milliseconds in query performance. From there, we're going to talk about considerations you should think about when you want to build data-driven applications on data lakes, such as indexing, right, is very important, concurrency, and query performance. The third item fourthly, we'll talk about how you can ship your apps faster, powered by data in your data lakes. So Rockset provides developer tools that allow us to integrate with it automatically to get millisecond query latencies at scale. And we'll get into this more when we actually do the workshop. And then finally, at the end, we're going to do a workshop where we're going to be using data from a public S3 data bucket that we already set up. And we're going to write analytical queries that will join, aggregate, and search on semi-structured data. So in this case, it'll be a JSON. And we'll be able to turn those queries into a RESTful API point that you can embed in your applications or do like a curl command and just make a regular post request and then get the results. If all of this is kind of like, okay, what did you just say? Don't worry, we're gonna get to this by the end of this. So it'll be very tangible by the end of the hour. Again, if you have any questions as I go through the slides, please post them in the chat box, and I'll also be taking questions at the end. Okay, let's kick this off. What is the current state of data lakes? And let's dive into that part right now. Okay, so as a quick recap, data lakes are meant to store lots of data, and I couldn't think of a better this is actually a GIF turned into an image because I can't do GIFs in PowerPoint for some reason. But yeah, like that suitcase represents all the data and ever more of your wishes of what you want to store in S3 data lakes, whether they're processed or raw. But actually the term data lake was credited by James Dixon, who wrote it in his 2010 blog post. And he compared it to a large body of water that comes from like various streams, and then people can use it for multiple purposes. And hey, from 2010 till now, it still stands true. Data could be in different formats, right? You can store it in a structured, unstructured, and semi-structured way. For example, JSON is semi-structured data. You can use store video files or picture files, which are also unstructured data. And obviously you can have structured data like SQL tables and stuff that you can store. But no matter the format, the end goal is you want to do some sort of analytics with that data to get insights that will benefit your products, your customers, and maybe internal insights of how the business is doing. So different enterprises use data and data lakes for different reasons to benefit the products, the business, or the customers. In a blog written by Kazina, and there was a research done by 451 Research by Matt Aslett, illustrates the growth in the adoption of data lake environments. So more than 58% of respondents says they're using data lakes to some extent, with a further 15% considering adoption. And out of the 58% respondents, around 23% of them are using data lakes for strategic purposes and tactical purposes. Now, I think this is really interesting because if you were talking about data lakes like 4 or 5 years ago, I would assume that the strategic purposes, I don't have research to back this up, but it would be much more higher than tactical purposes. So let's kind of break down what strategic and tactical means here. Strategic means decisions that are related to overall business trends and growth and like progress, right? And in these cases, the data latencies can be more forgiving because you don't need to have the data now. You can do reports and stuff, and then you can do your analysis long-term to figure out what that trend or growth is looking like. But when we talk about tactical decisions, it's related to operations that we do to realize the strategic part, right? It's more short term. Here it means data is immediately available to make decisions, operational. Like you get data and you need to analyze it in order to have some sort of outcome. And the chart that they shared before that I shared, it showed that strategic and tactical are almost like at the same level in their research. And so my tech talk actually is focused more on the tactical or operational side of how we use data and data lake. So more immediate cases where the data latency needs to be short and the query latency needs to be very short as well. Like there can't be much lag at all. And so in the last slide here, we're talking about the trends of how developers like me, I'm cloud-based, I don't use anything on-prem, and how developers are using data lakes. And if you look over here, there's definitely an increase of developers using cloud-based data lakes versus data lakes that are on-prem. And this is just showing the trend that a lot more companies and a lot more developers are moving to cloud-based data lakes. So let's talk about like why we're going to talk about S3. So S3, I feel, in my opinion, is a leading cloud-based data lake option. And it's kind of like the de facto for all of the companies I have worked at, literally. And the reason why is that, for example, you don't need to do capacity planning, right? It's cheaper, it's easier to use. If you use the Amazon CLI tools and developer tools and stuff, I think in under 10 lines of code, you can make a post request and send data to S3, right? And also has high reliability, right? When things are that simple, like it's going to be a very easy tool to use or a very easy data lake to use. So this is this slide is presented to show you why we're going to talk about Amazon S3 today. So even though we use S3 for storage, how do we make sense of the data, right? You have all this data, but what are you going to do with that data? So here we pop a query engine like Athena. So we'll stick for Athena for this example. I'm sure there are other examples as well, but Athena has a very standard SQL, which means that maybe, you don't need to learn a new language if you use relational databases like Postgres and MySQL. Athena is based on Presso, which is an open source software that powers Athena. And the great thing is it's completely serverless. So it's great to use for ad hoc queries on your large data lakes. But if you're building real-time apps on data lakes, is Athena enough, right? What are the pros and cons that you need to take in to use Athena for real-time application? And this is what we're going to talk about. So if you're doing occasional queries, you could use Athena to query data from S3, right? I'm sure maybe a few of us have done that. However, if you're building apps, you need a continuous stream of queries that are highly concurrent in nature. And it's not like a handful of like developers or scientists making queries on your data lake. It's something that's much more automated that's doing that, right? That's making queries on your data lake. Like some digital system, that's making the queries on your data lake. So you need highly concurrent queries, which are continuous in nature, and there's no time on the system, right? So what are some concrete examples of apps that kind of need those types of requirements, right? You can think about like if you're building like a customer 360 profile. Let's say you are an e-commerce company and you want to understand more who your customers are. You'll build a profile around them. Where did they shop? Did they do online shopping or did they go to a physical store? Did they return something? Did they talk to customer support? Did they write a review on a product? But you need to have that sense of data. The other thing that's really good for these type of application is personalized content. I mean, I know all of us are targeted. I'm especially targeted on like Instagram. The minute I'm on, I'm getting ads relevant to something that I previously looked for, and it's in my environment and in context of what I'm doing. And they do that pretty instantly, right? And so you need, in order to build real-time apps, you need to have that kind of speed, right, to capture your audience and your environment. So you essentially need a query system that is very low latency and is able to handle high concurrent queries. And these are the two things that your real-time apps need if you want to power data from your data lake, right? Because what happens if the latencies are large? You're going to lose that person from Instagram or Facebook or LinkedIn or whatever thing that you want to build, right? If you want to catch them in the environment, you need to query the data and you need to show it immediately. And you need to do that with very low data latencies. Okay, so today I'm going to talk about Rockset and how it can solve this and how it is actually able to. From there, we're going to compare it with Athena and cover the differences and similarities between these two systems. So I'm going to give a high-level view of Rockset and its technical capabilities and how it fits into tech stack and why it's useful to build real-time apps. And again, please ask questions as I'm giving the talk. I also have the chat box open. So Rockset is a real-time analytics database built for the cloud that allows you to run millisecond latency search, aggregations, and joins on terabytes of data. And the great thing is that you get fast queries out of the box. So when you think about fast queries, you're thinking about optimization, you're thinking about scaling. With Rockset, it's serverless, so you don't really need to worry about that. So Rockset has an S3 data connector that's managed in-house that allows you to pull structured or semi-structured data from S3 to Rockset. So it can automatically get indexed and querying. And the great thing is you do not need to manage any indexes or create any indexes. You definitely do not need to write any ETL pipelines or servers or create schemas like you would in relational databases and some other things. And Rockset supports high concurrency. And when you're thinking about improving data latency, when you have data pipelines and ETL pipelines, they can stretch that latency and make it a little larger. And so when you're doing real-time apps, those are some considerations that you need to take in. So what we're going to do is we're going to cover each of these points and talk about why these points are useful for building data-driven or real-time applications. But before we dig in, let's talk about how a few customers of Rockset are actually building apps on data that is coming from S3. So I'm going to quickly talk about Matter. Matter is a financial company that does sustainable investing, and they do investing in different assets and different funds. So in their apps, they have streams of data coming in from various sources like news feeds and reports and everything else. And they have over 20,000 plus feeds coming in every day. And they need to do sentiment and trend analysis. And based on these analysis, they need to figure out and suggest what investments to make for their clients. So a really good example that I like to bring up today, and hopefully it's on a sore topic, on an idea of taking immediate data is Evergrande. If you've heard of Evergrande, they're based in China. If you've read through them on Reddit or news or whatever, and they're deeply in debt and they're looking for, I think they're still looking to see if the government's going to get a bailout. But the fact is that the Evergrande deeply affected stocks in the crypto market. And if you Google it, you'll find all news about it. But the idea is like when these types of news come out, you need to be able to react to the data immediately. And so pulling streams of data from different sources that are sensitive news like Evergrande, storing it in S3, letting it get indexed by Rockset to obtain query results in seconds in order to inform customers of their recommendations of what they should invest is really important, because if latency is too high, they just sacrifice the company's profitability, right, and reputation, right? It's really, really important. So investment firms like Matter want to find the moment when something's happened so they can make changes in their investment decision. And they can't wait 1 day or 30 minutes for it. If some news reports come out and they need to switch pretty fast. So in Matter's case, they're using Rockset because the data latency is very crucial for them. Data latency is when the data arrives in the system till when it's available to make queries or make decisions. So although the data is being deposited into their data lake, right? They're getting the news feeds, they're sending it to S3. It's very important to be able to query the data as soon as it lands in a data lake, and then make decisions based on that data. So they use Athena. They used to use Athena, and now they use Rockset, and they're seeing better performance. So and also the most important thing is that they can deliver a lot more developer-focused applications, because they don't have to worry about maintaining pipelines, creating schemas that you would typically do if you've done backend stuff. So the last customer I wanted to quickly talk about is Ego Games. So Ego Games is an esports mobile platform. And the company transforms mobile games to esports by providing a virtual arena for like any users to compete in, to improve their skill, win prizes, and ultimately play professionally for money, right? So to understand what they're doing, they need to make a complex decision-making system, which can process a lot of data and get complex analytics out of it. So some of the things that apps needs to do to make decision on is, for example, are the competitions fair? Is matchmaking efficient? Are the leaderboards being updated by ranks of players, or who's playing the best? So they actually use DynamoDB as their transactional data store to store player information, right? And then they get acquisition and attribution data from a third-party system like CleverTap, and they store this data from CleverTap into S3. From there, they use Rockset to run complex SQL queries and then feed it into their rule engine so they can detect fraud and other things within seconds. And the great thing is you can join data from DynamoDB and data from S3, so these two disparate storage systems or sources, and join them and still get incredible performance without denormalizing data if it's nested data, or without sacrificing on performance, which some cases, if you're using other sources, that can be the case. So while the data is in the data lake for both of these examples, you don't have to wait minutes or hours to make decision on it. And by combining Rockset with your data lakes, you can power your data applications to return decisions within milliseconds. So that's very, very powerful for real-time apps. So now that we talked a few about these use cases and how some companies are using Rockset to index S3 data, let's go over why they started using Rockset and the differences between Rockset and Athena when querying data from S3. So the first one obviously is query latency. So on the screen, you'll see on the left side, we have Athena over here, and on the right side, we have Rockset. So the similarities between Athena and Rockset is that both of them are SQL systems, which means you can join and you can do group buys and you can do order buys. But actually the similarities end there. Athena is very much more of an ad hoc querying system where you might be able to make ad hoc queries. And when we talk about concurrency and selecting data in a large data set, let's say you need to pull out 10 records in a data set of 1 billion records, right? Athena now starts having some limitations. Athena is essentially mostly tries to store data in a columnar format, but in comparison with Rockset, Rockset stores data in 3 different ways in what we call converged index. So Converge Index unifies a row store, similarly like a MongoDB or Postgres, a columnar store similar to like Athena or Snowflake, like your data warehouse, and then finally in an inverted index like Elasticsearch. So Rockset builds these indexes automatically on top of your data lake, right? So you have data coming in from your data lake. Rockset puts these 3 indexes, indexes your data in these 3 different ways. So you don't need to create or manage these indexes. And because of Converge Index, your apps get low latency queries on large data sets. So for example, if you need to pull out 10 records in a data set of 1 billion records, your query should return within hundreds of milliseconds in Rockset. And it doesn't matter what the selectivity of the queries are. So on the last row of the screen, you can see that we cover the architectural differences between Rockset and Athena. So on this row over here, it says every query is parallelized and scanned. So Athena is essentially a parallelized and scanning system, which basically means you parallelize everything and then you scan each piece of data. While Rockset, queries are served from the indexes. So because Rockset indexes the data, you get better performance than scanning. And we're actually going to dive to this part further in the next slide over here. So in Athena, when data comes in, it can be parallelized and then it can scan each piece of it. And if you remember MapReduce, right? I mean, I'm pretty sure you guys know about MapReduce. It made this part popular where you have to spin up a lot of CPUs. So each CPU is scanning their own block of data or own set of files and then giving you the queried results. This is ideal for reports where you have to go through a lot of data and then get your results in a periodic form or time. So like Hadoop, if you work with Hadoop, this is probably pretty familiar. And for example, you might get reports every hour. But in real-time analytics, queries are very different. For example, you have many queries arriving at the same time, right? It's a very high traffic, high load. And the nature of queries are also different. You may join, aggregate, and search all in real time. And because of this, MapReduce isn't really ideal. You need an indexing-based system to get fast queries, like Converge Index. So Converge Indexing is, again, essentially you index data so you have low latency queries on data that's coming in from your data lakes. So typically developers think like when you're querying a data from a data lake, it's painfully slow, right? You have terabytes of data or gigabytes of data, and then you have to write all these queries. And I know my time at Udemy, I literally saw people waiting for 20, 30 minutes for a query to run. And I'm sure one or a few of us have had this experience in the past. It's not fun. But for the most part, when you complement Rockset with your data lake, you're able to get fast queries on semi-structured data because of Converge Index. So let's actually double click into Converge Index and see how this works. An example, we have two records coming into the database. We have a doc0 and document 1 or doc1. In real life, obviously, these documents would be very complex. They might be nested, they might be long. This is just a sample of what a semi-structured data looks like for the purposes of this tech talk. So Converge Index takes its JSON document or structured document and then spreads it to its individual keys and values and stores it in a key value store. And that's what you see here on the right side over here, a key and a value. The key value store gives you a feature of sorting all the keys in some sorting order. So finding a key in this key value store is relatively easy because it uses the index of the key value store. So Converge Indexing creates 3 different types of keys for every record, right? And we quickly mentioned this earlier. It creates a row key of the row store for the first 2 records, which is over here. So r.0.name and r.1.name. Those are the 2 keys that start with R. So and they're very similar as if you were storing data in Postgres or MongoDB cluster, where it's a row store where every record is stored in a row format. So you can find all these records inside the document very quickly when you use the row key. So now Converge Indexing also stores it in a columnar source. This is the next set, which is c.name.0 and then c.name.1. And so if you're looking for like the average age of a person, you can just look at all the C columns, like you can look at c.age, for example, and you'll get quick results. This is very similar to how data is stored in a warehouse like Snowflake or Redshift. And if you've used this, then you're familiar with columnar store. And the last one finally is the inverted index, which is s.name.druba.1. Druba is our CTO. And then s.name.igor.0. He's our engineer. He's on the system stuff. And now if there are queries, so now if you have queries where you're saying like, find me all the records where name equals, for example, Druba here, it'll do a 1 key lookup in the index and the index of the key of value store and then find the document where the ID equals that. And then it gives you the result. So it's very much similar to like an inverted index that you find in Lucene or Elasticsearch. So Converge Index builds all these indexes for you, and you don't have to configure or build or take your data lake data into like these 3 different types of system. You can use Rockset to unify these systems to get fast queries, meaning you don't have to copy some data to Elasticsearch to optimize search, or you don't have to copy some data to Redshift or Snowflake to get optimized queries or certain queries that you want to write. Rockset is able to handle queries that need columnar store, queries that need row store, and finally queries that need an inverted index. So here we're going to talk about how does Rockset pick the right index for your queries, right? How does it leverage that? So we have two queries that we're going to quickly walk through. On the left side over here, we have on the left, we have a Rockset system that automatically figures out that when I'm looking for a keyword, HPTS, the number of records or the selectivity is very high, which means that it could probably result in, say, like hundreds of records out of 10 terabytes of sizes. So it automatically uses the inverted index over here. So under the hood, we have a query optimizer that picks the inverted index for this type of query. Now on the right side, we have a query where we're basically creating a report of some kind where we're saying like, hey, how many times is this conference mentioned in this, my terabyte size database or whatever. And in order to find this, you need to do some scanning and you need to do some counting. And which is why it, in this type of context, the query optimizer picks the columnar store for this query, very similar to what Snowflake and Redshift does. And it gives you the results of each of those keywords that you're interested in. So the great thing about this is that you don't have to manage the index or configure it. Rockset does all of this behind the scenes. And the result is millisecond query latency on different types of queries that you write. So query latency is very crucial when you're building data-driven applications, like what I mentioned earlier, like leaderboards and things like this. The other part that's important that we haven't covered yet is concurrency. So let's go ahead and go into concurrency. I'm going to go over here. Okay. So, and Athena, when we talk about concurrency, we talked about Athena, and it's very great in the sense that it can use SQL, and it's very much used for ad hoc queries and stuff. But when it comes to concurrency, this is where it kind of changes a little bit over here. So let's say you have 10 users using your app that leverages Athena. The cost of Athena is pretty low in that sense, right? And you don't see significant changes. But when we start scaling to thousands plus queries per second, the cost significantly goes up in Athena. And the reason, again, is because Athena uses parallelize and scan. So every time it parallelizes and scans, there's a lot of CPU that's needed to scan the same data set over and over and over again. And so when you get to 1,000 QPS or query per second, it becomes less manageable. This is in contrast to Rockset, which uses an indexing system like Converge Index we just talked about. This is very different because the amount of data that Rockset needs to touch to respond to queries is far lesser than the parallelize and scan approach that Athena takes. So now let's talk about the architecture that allows us to query data lakes with low query latency and high concurrency. This is the ALT architecture, or aggregator, leaf, tailor architecture. And the three main components to this architecture that we're seeing here. We have the tailors on the left side over here, which I'm circling with my mouse. And we have the leaf nodes, and then we have the aggregators. So the tailors are taking data from sources like your OLTP or operational databases, your data streams like Kinesis or Apache Kafka, and then your data lakes like S3. The tailor components transform data from all of these formats into an index format. And these index formats are stored on this middle over here, which is the leaf nodes over here. So these leaf nodes stores all of these indexes. And then the aggregators on the far right are used for queries, which means that when a query arrives, these aggregators, they talk to each other and figure out what's the best way to run the queries on the index data. So now the interesting thing that you see here is that what we have done is that we've separated compute from storage, in the sense that compute is the tailors and the aggregators, so the left and the right, and then the storage is actually the leaf nodes over here, which is what stores the index. So this is very similar to like what some cloud warehouses do. Some of them do separate compute from storage, but we've actually gone a step further because we want to focus on real-time apps and not just like BIs and dashboards. So for real-time apps, we also need to separate compute, for example, ingest compute versus query compute. And these two things need to be separated for real-time database. So you'll see that when there's a burst of new writes happening over here, the tailors are the CPUs over here that scale up and down and that have no impact on query latency. So the query latency would be over here. Or performance on the aggregators, because these nodes are independent. So if you have a burst of writes coming, these aggregators and your query latency will not be affected. Similarly, if you have a burst of queries, let's say you're running an event and a lot of people are on your site, you may need to spin up more aggregators to handle the traffic. In this case, it won't affect the data latency where data, streaming in from these sources to the tailors will be affected. Your data latency should not change because these nodes are independent of each other. So this architecture is very critical to serve low latency applications on sources like data lakes. So now if you use a warehouse, this is very difficult for you to do because you cannot do writes and reads at the same time for a data warehouse. Typically for a data warehouse, you might need to back some of the data and then upload it periodically. The LT architecture lets you do both of these things at the same time. So support high write rates as well as high query rate on the write side. So Rockset uses the ALT architecture as its kind of like its blueprint or underlying bones, if you will. And actually this architecture is not something like that Rockset created. It is actually really used on like many web companies like Facebook and LinkedIn. And then you actually use it to power their own real-time apps for like ad placements or fraud detection and things like that. So the salient point here is that the selling point of this architecture is that data is mutable. So you'll know that some databases are immutable, some are mutable. Rockset is a mutable database. And it's a database which means that when writes are happening, you can make queries at the same time. And here we have a chart of the differences between Athena and Rockset. So on the left, we have Athena, and on the right, we have Rockset. So in Athena, let's say you have a schema change. Let's say your data is changing, you have new fields appearing. It's very much when you're dealing with real-time data and you're getting data and it's coming into your system, it's very much a use case that can happen. So in Athena, you might have to configure it to say, to use Hive Metastore. So you might have to make some changes in those things to be able to tell Athena like, hey, look, there's another field that you might want to process. Whereas in Rockset, it automatically processes everything that's coming in, including schema changes. So it's a very flexible schema. It indexes the schema as well as the data of your incoming data set and then creates the index without you needing to do anything. Also for Athena, if you're running Athena on S3, since S3 is not mutable, right? You can create new objects, you can write objects to S3, which essentially means you can insert data into your data set. But you can't really update specific fields of your data in Athena, right? I don't think you can do that. So in Rockset, it's completely mutable in this database where you can actually update every field in your database very quickly. And the great part is when you update your database, you don't need to re-index your whole document. You just re-index the new data that's coming in, and this saves on some IO as well. So over here, we're going to talk about the schema changes. So for Rockset supports strong dynamic typing. In general, having a strong schema is very important for querying, right? In this example, we're seeing that there's basically like different records showing up, and you'll see like the age field shows up, but then on this third line here, there's no age field. And then if you look on the zip code, you'll see that this data type is an int, but then if you go on the second column here, the second doc, you'll see that it shows up as a string, right? So you'll notice that the docs are not the same. There's some fields missing, there are mixed data types within a field. So Rockset doesn't type check and reject records where fields are missing or there's a mixed data type. It actually accepts all of these records. And then Rockset automatically creates the schema for you without you needing to define it. So, and so if we go over here, we can say that in Rockset, the queries are very strongly typed. So if you make a query and the types don't match, it will give an error. And this is really helpful for us when we build apps, because it's always good to find bugs at compile time versus at runtime. And this is an example to show you that the queries are very strongly typed. And then finally, in Rockset, there's always a schema in Rockset. But again, as I mentioned earlier, it's nothing that you have to define like you would if you're creating a table in MySQL. Rockset creates it and shows you the schema. And when we get to the workshop, this is going to make so much more sense. But this is when you create a collection on Rockset, it's actually able to infer the schema without you ever needing to write one. And the reason it can infer the schema is because of how it indexes the data through converged index. So here you also have the option to index the data that you only want to index from S3 through field mappings. So you can selectively pick fields that you want to drop or transform at ingestion time. And if you look over here on the field mappings at the top, you can modify how much of the data or what data you want to index from S3. And you also have the ability to set a retention of how long you want the documents to stay in Rockset. So if you're dealing real-time data, you can get a lot of data, especially if you're dealing with like streaming data. So if you want to set this, if you want to set the retention date to 1 day or 30 days, you have the ability to do that. So to wrap up, Rockset supports high ingestion as well as fast queries. And there's also a benchmark that shows you that you can scale it, that you can scale, you can do fast ingestions at Rockset, which we're going to talk about next. So typically what happens is that when data is in your data lake, it's coming from, let's say, a Kafka stream. And because it's streaming and data at a high volume, the benchmark that we ran is called Rockbench, and it's an open source. And you're welcome to contribute to it as well. But what's going on here is that we're getting streaming data from, into our data lake from a Kafka stream. And we're trying to measure what is the data latency when the data is available in Kafka to the time it's queryable in Rockset. And on the far right, you can see that at 20,000 writes per second, the data latency for P50 is around 2 seconds. And this is at a 4x large instance. So at Rockset, we have different virtual instances, which you can scale your compute. And you can read more about it at rockset.com/docs. But essentially, when we scale these instances, the latency actually goes down, which is great. And you can read more about this benchmark at rockset.com/blogs. We talked a lot about the technical side of Rockset and why it's useful to power a low latency application, but we really haven't talked about developer productivity. So usually you might find that a lot of application developers, it's hard to consume data from a data lake first, and then the schema could be associated, the schema associated with it, maybe the developers are not familiar with it. Maybe they're not familiar about the scalability of the data lake or SQL. So what we've done here is we created a thing called Query Lambda, and it lets you create developer APIs for application that can leverage data from your data lake. So the devs on the application side can just get the API endpoint, which is over here. If you see the flag for URL, there's this API endpoint, and then developers can iterate over it or embed it in the application and stuff. So query lambdas are basically SQL queries stored in Rockset and executed through a RESTful endpoint. So when you invoke an HTTP post request, the system automatically runs the query lambda fresh every time. And this allows you to easily version control queries and integrate with your CI/CD workflow. For example, you can collaborate with your team members with these API links. And then finally, you can prevent SQL injections by embedding the query lambdas into your apps. So this is, again, we're going to actually do this in our workshop. But this kind of just wraps it up for our tech talk today on indexing data from S3 with 125x improvement on performance. So if you have any questions, I think I have some questions here. So please post them or feel free to talk, and I'm happy to go through questions. So we have one in the talk. Will this work with something like AWS Outposts as to support hybrid cloud or far edge use cases? Oh, interesting. I'm not familiar with AWS Outposts. Do you want to talk more about that?
I think if I remember correctly, Outpost lets you deploy on-prem, kind of like it's like managed remotely, but it can run in your own environment.
Oh, so we don't support on-prem. Yeah, Rockset is purely a cloud-based. So yeah, on-prem will not work for us.
Are you able to connect to what if there was a connection to an on-prem, like as if it was in another virtual machine somewhere?
Oh, interesting. I mean, I feel like everything is on cloud. So anything that on-prem shouldn't work, but I can come back and circle back with that on that. We have another question on how expensive is indexing. So if you go to the pricing page, there's we only charge for compute and storage, and we only charge for what you use. So I don't have the specific pricing for indexing. But you can go to rockset.com/pricing, and then you can, and we do the breakdown of the calculation. We use Lambda. Is it comparable in performance? You mean like AWS Lambda, or what do you mean by Lambda? Oh, AWS Lambda. So our performance when we write, so I'm not sure what the performance you're seeing in AWS Lambda. But with us, like when you write your queries and you're getting the data from your data lakes, again, the data latency is within seconds, so less than 5 seconds. And then the query performance on nested data and terabytes of data is within milliseconds. So that's the Rockset performance. I'm not sure what the AWS Lambda, I feel like that might be variable. But for Rockset, because of how we index, again, Rockset uses Converge Index, and all the data is indexed in 3 different ways, right? Row store, column store, and an inverted index. I don't think the systems like when you're using the systems, that might not be the case. I think we're the only one that really uses 3 indexes and index your data 3 different ways. So I feel like the performance for Rockset might be a little better, but I can't speak to the AWS Lambda stuff. Does that help answer your question? Okay, yeah. And if I'm sorry if I mispronounce your name. Is it Naga Raju? We're gonna do the workshop. So I think you're gonna get a feel if you do the workshop with us as well. Do we have any more questions?
You know, if we get more questions, we can take them as you go. So, but okay. if you want to move on to the workshop, I think that's a good idea.
Yes, let's go ahead. So before we do the workshop, I'm going to give you the previs of the workshop so we actually know what we're doing. So if you haven't created an account, please create a rockset.com account. And you can do that now. From there, we're going to use a public data set coming in from S3, which is step 2 over here. You don't need to do anything. It's already public, so it's fine. And then we're going to write, we're going to actually, what I'm going to have you guys do, I wanted you guys to see how Rockset nested data. Like, so we're going to ingest 2 different public data sets into Rockset, and then I'm going to send you a query to execute. And if you guys want to examine the data set and how the query works, you guys can do that in your own time for the purpose of saving time over here. And then we're going to execute our query Lambda on our terminal. So it should be super short and really fast, but then, hey, get real-time analytics within 10 minutes. Okay, let's go ahead and start the workshop. We'll wrap up with indexing S3 using with Rockset. You get low data latency, high concurrency queries for serving application. It's really easy to use, and because of query lambdas, you get increased developer velocity, and yeah, it's pretty cool. So, okay, so let's go ahead and I'm going to get out of this screen. And I also, when you create an account, I want you to go to community.rockset.com because I kind of want you guys to share your results on the community as well. Like a snapshot of you like executing the query lambdas and talking about the, I guess if you want to provide feedback for this tech talk, that would be great too. So when you create an account on Rockset, go ahead and also sign in to the community.rockset.com. And I will paste this on the chat. And then I'll put rockset.com. Oh, rockset.com. And then we'll be going. So I'm going to work through emojis here. How many of you have created an account? Or wanted to, so to do the workshop, to do the giveaways, we're going to do the workshop and we're going to post in the community, and then you qualify for the giveaway. So we're going to be doing like $400 worth of giveaways. It's going to be quite a bit today. So if you haven't created an account, go ahead and do that and then show me. So Nagaraju created it. Please show me if you're online and you don't want to type it in, show me through an emoji that you create an account, and then I know like everyone's kind of on board, and then we'll go ahead and continue. Okay, so we have 2 people who created the accounts. I'm going to give you guys a few more minutes to create the account. If you're in the process of creating an account, let me know that as well. That will help me a lot. And I'll give you guys a few minutes and then we'll go ahead and move on. Okay, so at the end of the workshop, when you guys post on the community, I will know who posts and I will be able to send you an email and you will get your gift cards. So when you sign in and everything, I want you to go to console.rockset.com and you'll see the console that looks something like this. So if you're here, just show me an emoji or something that you're there so I know that you guys are there. I think we have Phoebe is joining. Shankar, are you going to join us in the workshop? I can't see all of your names for some reason. Okay, so I'll go ahead and continue. And if you guys need me to slow down, just let me know that you need me to slow down. So first thing we're going to do is we're going to go under collection and we're going to go ahead and create our first collection over here. So I'm going to go ahead and click on this. And then if you scroll to the bottom, we're going to use sample data sets. So I'm going to click on this. And then I'll pause here. Is everyone up until this point? I feel like everyone is pretty shy. And I'm not. Okay, cool. Thank you. Okay, so the first data set that we're going to do is you're going to give this a name. We're going to call it, I'm going to call it SV data 1, just for, actually, we're going to use, let's go ahead and use movie ratings, and I'm going to call it SV data 1 ratings. Okay. And then I'm going to pick the movie ratings data set over here, and then I'm going to keep it under comments. That's fine. And then you'll see that we get the source preview on the right. So this data is definitely coming from S3. And at this point, we didn't have to define the schema or write any ETLs or things like that. So all we're going to do is when we do this, we're going to go ahead and create the thing. Oh, sure, Elena, thanks for joining. That sounds great. Sure, go ahead. If you are joining in the workshop, you can do this also on the quick start guide at rockset.com/docs. And if you post in the community, I will PM you and you will get your gift cards. So I'm gonna go ahead and create this. And then right now, what's happening is when you create the collection, Rockset indexes it through what we call Converge Index. And so this means that all the fields and all the data are being indexed 3 different ways. And so once this is done, we'll be able to query the data. So while this is setting it up, we're going to go ahead and I'm going to click on collection again, and we're going to create another collection. And I'm going to click on sample data sets again, and we're going to actually do movies now. And I'm going to call it SV data movies. And then you'll see again, we get a source preview. And you'll see what the schema looks like. So this is again, Rockset indexes the data and it's able to infer the schema. So when we create this, we're going to be indexing the data. So now if we go under collections, we have one collection that's ready to go, and then we have another one that's being created. So we're going to go ahead and I'm going to paste a query for you to use. So I don't have to, we can save on this really quickly. And again, let me go ahead and modify this query really quickly. But what we're going to do is we're going to get the top 5 movie titles with the genres they belong to. So I'm going to paste this query and I'm going to walk you through it. So go ahead and check the chat really quick on this. And I'm going to show you what this looks like. So give me 1 second while I pull this up. So I'm going to go ahead and query this collection. So when we run this, you'll see that we're able to see the data, but you're probably thinking like, okay, great. This is just select star, like if you run SQL, this isn't anything major. But the one thing that I want to point out that if you see these data sets over here, you can see if you hover above them, you can see like their mixed data types and things, and you can also describe the data set and you'll get the schema. So what I'm going to do is I'm going to comment this out. Or actually we can just uncomment it. I'm going to open up a new tab really quick and I'm going to paste this over here. So I'm going to format this really quick and I'm going to walk you through this. So on this ratings, you're going to change from this part over here. You're going to change this to the collection that you created, the ratings table or the ratings collection. So in this case, my ratings was called Commons SV data ratings. So I'm going to paste that over here. And I'm going to keep the alias. So just paste the Commons SV data one ratings and then keep the MR at the end. So I'm just aliasing this collection. Mine are still under creating. Is that something wrong with my configuration? No, it should be fine. No, it should be fine. If it's creating, just let it create. If you go back to collections, you see if they're ready, then you should be ready to, it should be ready to query. And then the other thing that I want you to change, besides this common from this rating, I want you to change common movie collections, MW. I want you to just change common movie collections to the movies collection that we created. So remember on the S3 public data set, there was a ratings collection and movies collection. Just change this part to the movies one. So in my case, I called it Commons SV data movies. I'm just going to change that to this part over here. And then it should run. And now you see that this is working. But I want you to know that when we did this, we're actually taking a nested object. And you can investigate this later by yourselves. But we're taking a nested object genres and we're unnesting it. So typically, if you use other sources, you might have to do data denormalization and things like this. With Rockset, you don't need to do that. So if we go back to genres really quickly, and I'm just going to show you this really quickly. I'm going to copy this and just change this to, instead of ratings, I'm going to just change this to this part here and run it. I want you to see that genre is actually nested data. So you see that we have an object over here, and then we have an array of objects. This is nested data. This is something that typically in other systems you would denormalize. But again, with Rockset, you can just use the unnest. And at this point, again, we didn't have to do data denormalization or anything like that. Cool, it works. Thank you. Okay, so still, once you create this, we're going to go ahead and then save this as a query Lambda over here. And then I'm just going to call it QL1. And then I'm going to create the query Lambda. And then all I'm going to do is that you're going to need to create your API keys. So just get your API keys. And then when you go to the query Lambda, you're going to paste your API key over here. So just get rid of these brackets and paste them in. And then all you're going to do is you're going to copy this and then paste it in your terminal and it should work. Yeah, I mean, I guess the easiest way that you can do this is just, I'm going to delete my API keys. So I'm just going to put my API keys here. And I'm going to get my API keys and just copy it, go back to the query editor. And I'm just going to delete this and then put this here. And then I'm going to copy this command. And then I'm just going to open up my terminal. Let me see if I can share my whole screen really quickly. My whole screen over here. Okay. And so I'm going to make this a little bigger. And then if I just paste this, we get the results. So this is how it typically works when you're dealing with Rockset. So your queries will be executed fresh every time. So now the last step that I want you to do is that you can just take a picture of like what the sample data set does, something like this. And then if you go to community.rockset.com, just go ahead and create an account and then just post on this account like SV data meetup. And then if you want to give feedback on this tech talk, that's great. And I want you to just post it under showcase. So if you go to random showcase, and then you can just insert the picture that I just did over here. Where is that? There we go. And then I'm going to say, you know, hey, the meetup was great. You can say whatever you want. And it was great meeting you all. And then when you create the topic, or at least 15 create Nadine. Okay. I will see who you are and I will get you the gift cards. So that's all you need to do. And then once you do this, you qualify for the gift cards. So assuming that not all of you did it, there is a potential to earn quite a bit of cash. So I will get that to you at the end. And I guess this wraps it up. And I'm happy to take any more questions that you guys have. And I feel I lost my text box or my chat box, but yeah.
Let's see. I don't know if you already got this question.
Oh yeah, my data sets are still being created, so I will drop now. We'll come back and follow and get started and guide and complete the remaining. Great session. Thank you. Sure, no worries.
Okay. All right. So it sounds like you got some people working on some stuff there, and I missed it. Did you give them instructions if they want to complete this after the
yeah, actually, as long as they post on this, I will know who they are from their email addresses, and I can send them an email and follow up on here, but they need to post on the community and then they will get the gift cards.
Okay, you mean in your community, right? Okay.
Yeah, the Rockset community. So please share. I'm going to paste this again. Please share your results here, and I will send you some gift cards. And they're going to be cash gift cards. It should be cool. Yeah, sure. No worries. Just whenever you get a chance, post it, and then I will get you the data. As long as you put the data meetup, I will know who you are, and then I will get you it. And just include the screenshot as well, so we can avoid bots and things like that. So something like this is just fine. And I know you guys did it. But yeah, okay, I didn't ask this question. Now with the show of emojis, how do we feel about indexing S3 data? Let me see your faces or your emojis. It was pretty easy, right? Yeah, it wasn't too bad. I think this is pretty cool. So yeah, this wraps it up for my tech talk. So I hope you guys enjoy it and enjoy the session.
Great. All right. Thanks a lot, Nadine. And looks like you got some applause there.
Yeah. Oh, I didn't see anything, but yeah.
No, I don't know if is that your dog?
Oh, my dogs. Yeah.
Excited. Okay, good. It's over now. You can play with me. Okay, great. Well, thank you very much, Nadine. And again, thanks for everyone for coming. I hope you enjoyed the talk and the hands-on experience. We'll try to do more of that hands-on experience as we go along, because I think that's value add to see exactly what it takes to get something going. And again, we are about to set the date for Subsurface 2022, which will be the end of January. We haven't set the exact date yet, though, so keep an eye out for that. And otherwise, we'll look forward to you joining us for our next meetup, which will be next month, and it will probably be on Project Nessie. All right. Thanks a lot, everyone. Have a good one.
Yeah, sure. Thanks, everyone. Okay, bye.
Okay, bye-bye.